stand up, 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 next to your desk. Here we go. All right. You ready? I know. Here we go. Hands together. Turn to your neighbor and say namaste. Very good. Here we go. The first family is a linear graph. A linear graph is a straight line. This happens to be a positive line because it's going up. Hello? It's going up to the right. Very good. A straight line is a linear function. The next function we talked about is, if it's opening up, it's positive, and down would be negative. Back to namaste. Here we go. The next one. If you take the absolute value and then curve it a little bit to make it a parabola, this is called quadratics. By the way, there's another Q one. So when you're writing this, spelling isn't that big of a deal, but if you write quartic, I'm not going to take it. Here we go. Back to namaste. All right, take that quadratic and bring one arm down. If it happens to be the left arm and the right arm, this is called cubic. Repeat after me, cubic. Cubic. Very good. If you drop the other arm, that would be the negative cubic. So down on the right is negative, up on the right is positive. Always tipping to the right. All right, here we go. Back to namaste. All right, here we go. Stand up, Adrian. Here we go. Don't die. Here we go. All right, here we go. Back to a quadratic, right? And then bring it down to a W. Adrian. Down to a W. This is called a quartic. A quartic. Quart means 4. How many times does that thing cross the x-axis maximum? Could be 1, 2, 3, 4. Because if that thing went over just a little bit, it could be 4. So that's the degree as well. That'd be a quartic. All right. Back to namaste. Here's the best one. Ready? All right. Back to quadratic. Drop one down. The quadratic is a square, right? The inverse of a square is a square root. This is a square root function. All right, very good. Back to namaste. Now, a square root function looks very, very similar to something else. If you see a square root function, you shouldn't see it go past that line. So you just see like stopping at a point. If you see something like this, hello. If you see a tail, if you see that little the y-axis, right? So here's the thing. Go down to a deep lunge, okay? All right? This is the inverse of it. It's easier to do it this way. Here you go. Straight up and down. Notice that you're making the letter L, right? This is a logarithmic function. So straight up and back down for logarithmic. All right? Yeah. Or if it would go, that would just be the flip of it. Yeah. Yeah. So we just did the flip. So just pretend you do it upside down. It's easier to do it that way. All right? Versus, now there's a logarithmic, versus if you go back to your lunge and do a straight x-axis and curve up to the right. Since it's straight on the x-axis, this is exponential. Repeat after me, exponential. Very good. Back to namaste. And those are all your families that you have to know for tomorrow. Have a seat, 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 have a seat. All right. Here we go. So on your notes, here we go. If you want to remember these yoga moves, right? If you want to remember these yoga moves, imagine the function is your arms, right? And there you go. Right. Yeah, there's your hands. Right there. Yay, there's your hands. Oh, that's a broken hand. Okay. Right? Yeah. Okay. Versus absolute value, that is a V. Sweet. Yay. So that's your yoke. Oh. Well, there you go. There it is. Oh, well, okay. That guy was in woodshop. Here we go. Yeah. So a quadratic function is that you. Sweet. Yay. Oh, yeah. All right. Now, this one right here, right, is that cubic. This one's kind of hard to see, But a cubic function, if you can extend it a little bit, the cubic function can cross the x-axis up to, yeah, cubic is 3. A cube is 3 times, right? Cubic is 3 times, because a cube is 3-dimensional, right? It's a 3-dimensional square. So, again, that would be the cubic function. Okay? All right? Quartic is when you make that letter W with your hands. Joy. All right, here we go. For this one, remember you take your right hand, right, and then your other hand is just kind of dangling down this way. Well, that's something. All right, this is now a dress. Here we go. Yep, that's a dress. There it is. All right, square root. This, my dears, if you were to, is the inverse of a square function, because if you can imagine the other half of the u, it's just half of the parabola. So if it looks like half of a parabola on its side, it's square root. Yay? If you see a tail, however, if you see that thing going on forever and ever, this is the one, oh man. Yeah, I'm not quite sure how to make that picture, but that's okay. But if you see that tail, like you see it extending a little bit, and notice that the tail is parallel to the y-axis. If it's parallel to the y-axis, in other words, it's like straight up and down, that's the logarithmic. So think of like the long part of the L in logarithmic, right? So if you think about the long part of the L in logarithmic, that's how you know it's a logarithmic function. Yay? Versus if the tail right here, right, there's a tail, is parallel to the x-axis, right? Think about the x in exponential. That would be an exponential function. Yay? And that's how you can tell the families. So, you got to have these families memorized by tomorrow, because I'm going to give you a picture and say, what family is it? And absolutely, like if you point to Adrian, she's part of the Stacy family. Hey! Yeah, all right. Yeah, you got the wrong notes. No, you have the right notes. Did you not get the shape part? Yeah, there's 2 notes in there. There's 2 notes in there.
I don't have any of these things.
Yeah. Okay. Yeah, there's 2. Okay, so you have the intercept notes? Do you need the intercept notes? There you go. Yeah, there's 2. All right. No worries. Remember that this whole section is called graphical analysis. When you're looking at a graph, there's so many things that you can analyze about it. One of those things are the intercepts. These are pretty easy. They're so easy. Here's the deal, right? You're just looking at a graph. So if it doesn't look like it crossed perfectly, you can give your best estimate. So for example, if it's between 1 and 2, but it's closer to 1, you can do 1.3 if you want to, or 1.5, whichever, as long as you're close, and I can see that you know exactly where those intercepts are. So, have I seen? Here we go. Let's talk about x and y intercepts. Yes, love. Let's hear it. Yes. Yeah. X and exponential. Excellent. Here we go. All right. The x and y intercepts, we talked about this before. The x-intercept is where it crosses the x-axis, or touches, right? It could just touch it and then bounce back up. Then that happens for the touching part, right? It could just touch it and then bounce back up. That one is called a double root. Right? We'll talk about that later, but yeah, that's a double root. If it touches it, if it crosses all the way, then it's just one root by itself. Okay? Yeah, it's the one solution one where the solution's on the x-axis. Yeah. Okay? For the y-intercept, that's where it crosses the y-axis. Okay? The very first question on tomorrow's quiz are, what are 3 other names for the x-intercept? And those are, Repeat after me. Roots, solutions, or zeros? You didn't put the E in there? It's okay. Zeros. No. No. Unless I can't tell the difference if you're saying quadratic or quartic, because I've seen some quadratic stuff. I don't know. It's weird. Yeah. Yes, love. Is there a word bank? Heavens, no. You gotta know them. You gotta know them. Yeah. And you will. And you will. Okay. All right. Here we go. So it's days around the world. This is what you're going to be practicing. It doesn't say so on the paper, but instead of giving you a whole separate assignment on naming families, let's do both things together. So for your around the world, you're going to do three things. 1, name the family. 2, x-intercept. 3, y-intercept. So for this one, what family is it? Linear. This is definitely linear. Okay, so make sure you name the family. Just practice naming the family. The x-intercept, where is it at? Yeah, -2, 0 is right here. The y-intercept is at? Yes, it'd be at 0, 4. It's that easy. It's that easy. Okay. Second picture. Family? Linear, again. Yay. X-intercept? Yes, -3, 0. And y-intercept? Yeah, 0, -6. It's so easy. So easy. That's it. I mean, seriously. Yeah? What family? What family? All together! There it is. Quadratic. Yeah. Quadratic. Yay? Woo! What is the x-intercept? Yes! You can! You can have 2. Absolutely. You can have 2 x-intercepts. So the first one's at? Oh, 0. Yep. And? 1, 0. I was listening to you. There you go. And last but not least, yeah, there's 1 y-intercept at 0, -4. Yay? Yeah. Very good. So, there can be 2, 1, or none. And we'll talk about the none next time. Yay? Yeah. All right. Last but not least, this is quadratic. Yeah. Quadratic. Okay. Where's the x-intercept at? Yes. Is that the only one? So it's a double root. Exactly. So we're at 2, 0 for the double root. The y-intercept is at 0, -4. All right. Analyze this. For every graph, could you have more than 1 y-intercept? No. These are functions, right? For a function to work, there's something called the vertical line test. Yeah? Therefore, it can only cross, yes. Therefore, it can only cross the y-axis once. That's why for every single one, you'll only have 1 y-intercept. Question. Why is it a double root? Why is it a double root? Excellent. We're going to talk about the solutions for a quadratic. Turns out there's always 2. If it touches just once, then it's the same solution twice. Yep. Yeah. No, that one crosses, so it's just a single root. Yep. Yep, yep. Yep, yep. Yes, love. Then it's not a function. It's a relation, but not a function, right? A function has to pass the vertical line test. All of these are functions. Yay? Awesome sauce. All right, listen up. Here we go. Oh, wait. Did I give you this part? Yeah. I did? Oh, let's keep going. All right, here we go. Family, family, family. Cubic. Cubic. Very good. This is cubic. How many intercepts do you see? Almost. There's 2. There's 2, but one of them is that's a double root.
Wait, so what's a double root?
Excellent. When it touches but doesn't cross over. into the other side. It touches and then bounces back. So a cubic function has a degree of 3, right? That means there's 3 answers. There are actually 3 answers here. That's 1, 2, 3. So in other words, the answer 3 right here is the same answer twice, right? When we get into factoring and stuff, you'll see that you can have a couple of the same factors. Yay? So my x-intercepts are at? Yeah. Yes. Roots are only on the x-axis. Root solutions of zeros are on the x-axis. Y-intercept. That's it. That's it. Right? 3, 0. Is that right? Okay. And then the y-intercept, kind of hard to see. Is it at this one or this one? Where's the y-intercept? It's definitely 0, 0. It's the closest one is at 0, 0. So again, just one y-intercept. Yay? All right. What's family? What's the family? Yeah, it's cubic. If you can see it, it only crosses 3 times. 1, 2, 3. So this is cubic. You see it? 1, 2, 3. Yeah. Yep. It's cubic. Okay? All right. So we're at -3, 0. Excellent. Take a look at that example again. Was there a double root? Yeah. So if it's a double root, then that counts as twice. So you have the single ones and then the 2 in the middle. Yay? Okay. What's the y-intercept? Oops, I didn't finish. 2, 0. Yeah. Sorry about that. What's the y-intercept? Yeah, it's definitely at 6. Yeah, if the take a good close look at the graph. Some of you guys are gonna miss it just by 1 because you're not taking a look at where it actually truly crosses. Because it could look like it crosses at 5, but yeah, just be careful. There's definitely 0, 6. Sweet. Okay. All right. What family? It is logarithmic because it's parallel to the y-axis. The y-axis, right? So if it's going straight up and down, this is definitely logarithmic. Okay. What do you notice? There's no y-intercept. It's still a function. It just doesn't cross over into the y-axis part. It can, but this one in particular does not. There's actually something called an asymptote. Has anyone heard of asymptote yet? Yeah, an asymptote. You don't touch your asymptote. All right. It's kind of like a barrier. So you can see that at x equals 1, there's a barrier that the line doesn't cross. Yeah. Thank you for bringing that up. All right, so I need you to open your mind to the concept of infinity. All right, so pretend there's a barrier between us. Actually, it's working for you right now. Have you heard about physics? You're not really sitting on that chair. Like all your atoms are actually pushing against each other, so you're not actually touching that chair. Okay? Yeah, if you haven't heard of physics, so you take a look at atoms. Atoms like repel each other, so you're actually floating above that chair. It feels like you're touching, but you're not actually touching the chair, right? So if you're the line and the chair is the asymptote, you get closer and closer to it without touching it. Therefore, it's not like a straight line. It just keeps on getting closer and closer towards infinity. Yay? Yay! Yeah. I'm actually floating on this floor. Yeah, and every time you walk, you're actually falling towards the earth. That's what gravity is. You're falling towards the earth. Right. Yeah. I heard it. What was it? What was it? 2, 0. Thanks, love. Yeah, physics is fascinating. It's fascinating. All right. Last but not least, what family? What family? This is exponential because it's parallel to the x-axis. Right? So this one is exponential. What's that? All right, here we go. For the x-intercept, this is what I was talking about. Give a best guesstimate. Let me hear it.
1/2.
1.5. 1 3/4. Okay, it's about 1.5. It didn't look like exactly in the center to me. So I don't know. I'll take 1.5. So 1.5, 0. I thought it was close to 1.6.
Yeah.
That's not 1.5. It's 0.5. Thanks, Lumpy. All right. And the y-intercept? Yeah, that one. Okay. Second one, 0. 0.
Oh my gosh, I'm really messed up.
Me too. It's all good. All right. Yes, Miss Abigail.
I don't understand how double root counts.
You don't understand how double root counts as 2. All right. It'll get more clear to you when we go into factoring, but just know that the equation of the line, right? The highest exponent tells you how many roots are. So if it's a quartic, there has to be 4 answers. Okay, so in the quartic function, there has to be 4 answers. Therefore, when it just touches and bounces back, that counts as 2 of the answers, and the arms would be 1 each. So 2 plus 1 is 3 plus 1 is 4. Okay? We'll talk about double roots more in a little bit. I just wanted to introduce that phrase to you so it does not be a surprise. All right. Are we ready? Question. Square root function a little bit more. Absolutely. Do you know what a square function is? A quadratic function is like this. So So the inverse of a square is a square root, right? So when you take the square root, there's a positive and negative side. Usually we just take the positives. That's why we drop the arm down. And then since the inverse, then you just tilt it over to the right a little bit. So it looks like, let me go back to this, right? There's a square root. Yeah. So if it stops, like there's no tail, if it stops, it's square root. Logarithmic, you have a tail, so it keeps on going. Excellent, excellent. All right, here we go. Your activity for today. All right. If you take a look at that slip of paper it gave to you, that is the start of the gallery walk. There's 24 of them. Do all 24. 3 things. Here we go. The name of the family, the x-intercepts, and the y-intercept, if there is one. All right? The option assignment will be at the front when you turn it in. And it says the law of the donut in the back, and then girl attorney, boy attorney on the front and on the back. Hang on, love. Here we go. Tomorrow you have a quiz. So if you do the option assignment, each side is worth extra credit. Each side is worth 5 points extra credit. Make sure you show all your work for whatever side you are doing. Okay? What's up? Yeah, you're going to turn it to me tomorrow. Oh, it's up to you. Yes, ma'am. Yes, absolutely. All right, here we go. Go ahead and start on your section and go all the way around. Go all the way around. Woot, woot. I think I just made it.